Hello, my name is Marco Moschido from CMS Systems, and today I'm going to show you how to configure flow metering. Now, a flow meter is a logical entity that can be associated with a filter. As that filter matches packets, the flow meter can sample the number of packets and the associated number of bytes in very, very small time intervals, up to as small as 10 milliseconds. And it records this in a database, which the user can then export and plot on a chart. Now, why would somebody want to do this? Well, if you're able to sample in very, very small amount of times the number of packets received and the number of bytes received on a particular flow, then you can look for burstiness. And there is an issue a lot of times with customers misconfiguring shapers or assuming their shapers are actually behaving properly when they're not. And actually, they end up transmitting very, very small bursts that we call microbursts. So very, very small bursts in packets, which a carrier class policer would then mark for discard. And then the customer might say, well, why are you discarding packets? I set up my shaper appropriately, but in fact their shaper is misbehaving and your policer's behaving properly and discarding packets. So we're able to find these very, very brief and very high bursts in traffic using this flow metering feature. The flow metering feature is available in GenMX version 2.1 and later. If you want to look at your firmware version, of course, you go to System and Info, and you'll see it here. So I'm running GenMX 2.1. Typically customers would use this off a CMS Systems passive optical tap. So the passive optical tap effectively makes a copy of the light on a fiber and would hand it to the Prova X, and we would be able to meter that traffic. You could also use a mirror port or a span port off of a switch or a router. In this case, what I've done is I've tried to emulate a bursty flow by creating two streams. One stream that's steady at 10% line rate, and the other one that very briefly bursts to 50%. So we have a steady flow here for 1.5 million packets, and then we burst for some 100,000 packets. So we create this little burst, and this is going to happen periodically because I put it into a flow with a loop, and my loop is infinite here, where we're going to run the steady and then a little bit of a burst, then steady and a burst. And I want to show you how the flow metering function can actually sample this and display this information to the user. The first thing we're going to do is create a filter. So we're going to create a filter, and in this case it can be a catch-all filter on port 1. Excuse me, on port 2. So I've created this filter on port 1, and what I'm going to do is I'm just going to take it and I'm going to move it to port 2 because I made that mistake. So here we have the filter, which is the catch-all filter, and I'm going to enable it. And we're going to associate a meter with this filter. So to do that, I click on the meters tab and I create a new meter instance. This meter meter 1 will detect microbursts. So this is what's going to sample the traffic on that filter. So I can set several different things here. I can set the interval for which it takes samples and the duration. The only thing you have to keep in mind here is that at the fastest rate of sampling, which is 10 milliseconds, I can have a maximum of 6 hours. That's because the maximum samples that I can take with this feature is 2,160,000. It'll build a file with entries, so a CSV file with entries for each of the sample results. And the number of samples can't exceed 2,160,000 samples. So you can play with the sample interval or the duration and adjust it to your needs. Here I'm going to do something very simple. I'm going to sample for 1 minute at a 10 millisecond sample interval for a total of 6,000 samples. So I'll go ahead and enable this meter. If I go back to my home screen, I'll show you that the traffic I set up in that flow is going to start generating from port 1 to port 2. So let's pretend that port 2 is the traffic that we want to sample off a passive optical tap or a mirror port off a switch. All we need to do is go to that filter that we set that would catch all the traffic that goes to that port 2. And now what I want to do is I want to actually peer it to a flow meter entity, and that flow meter is the meter instance that I just created, meter 1. So I'm going to go ahead and apply those changes. So now this filter is associated with this flow meter, and this flow meter can start sampling traffic that's being matched by the catch-all filter. And you can see here that traffic is in fact matching that filter because it's a catch-all, obviously, and you can see the peered packets counter is increasing. So what do I do to start my meter? I simply press the play button. So you'll see here that the meter will start sampling, and it'll show you how many samples it's actually taken and the remaining time for the test. Okay, now that our test has completed, we want to view the data that's been sampled. So what we do is simply press the up arrow to export a CSV report. And you'll download that report, and I'm going to open this up in a spreadsheet application. So you can see it here, the CSV file that contains 6,000 samples. It shows it has a little bit of a file descriptor here with the meter name, at the interval, which was set to 10 milliseconds. The duration of the test was 1 minute, and we have in fact 6,000 samples here, each appearing as a separate row within the spreadsheet. So if I wanted to plot this, I'd simply highlight the data, and I'll insert a chart that'll show you that indeed we are getting, as we set up in the flow, a steady set of packets for 1.5 million packets transmitted, and then a very brief 100,000 packet interval where we burst to 50% of line rate, and that happens periodically. So you can see that data here quite easily in the chart. So I hope this helps. If you have any questions, please email us at support@siamasystems.com.